Hi, welcome to Pre-Cal lecture series. And today we are going to cover the section 3.6, the rational functions. In this chapter, we covered two functions. One is a polynomial, and now we're going to cover the second one. We call it is the rational functions. Okay, and so let's go to our lecture notes and start to understand what is rational function and what are the key characteristics we need to know about the rational functions here. Okay, let's go to the worksheets here. Okay, so this is our lecture note here. Okay, so the first thing is here. So what is rational functions here, right? So we define the definition, we defined rational functions. We define the Rx is like R is rational. So we have is the rational, that means it's a ratios, right? So it's a fraction of the two. We have a Px and the Qx. Both here, Px and Qx are the polynomial. Okay, so both of them are the polynomials here. And in here, so we assume here, like also if the rational functions, right? So we assume here Px and Qx, they have no common factor. Okay, so they don't have a common factor. That means if you factor them, they cannot cancel each other out, because after you cancel each other out, some, they change the properties of the rational functions here. Okay, so we know the rational functions is the fraction of what? Of the two polynomials here. Okay, so now we also, so right now this is the first definition about what is rationals, right? Now we also need to take a look, we're going to see what is the vertical and the horizontal asymptote. What means the asymptotes here? That means, the graph will getting closer and closer and closer to this line, but will never touch it. So that's why we call this asymptotes, getting closer and closer. So we have two kinds of the asymptote. The first one we call it is the vertical. So we call this the vertical asymptote for the functions, for the function f of x, right, equal to y. So what is the vertical asymptote? That means, like we say, is the value, it's a line, right? So this is the line here. So this is a line. So this is, for example, this is, we use the dotted lines here. This is like an A. So this is, we call this the vertical asymptote. That means the value of x, right? So the function value of x can get very close to this line. So they can go close to like this way, go up, right? So that means this function, this is my function f of x here. It will going to be very, very close to this asymptotes here. So this asymptote, because this is a, right? So this asymptote, right, is x equal to a. It will get in very, very close, but it will never touch it. Or, you can approach from many different directions, right? So, or your function can go like this. This can go down here, right? So you can go down like this, and then this one's here, right? So this one's here, you can say, this is an asymptote also. So that because this function, this is a red function, right? The gx here, this can be also getting closer and closer and closer, right? So that's what we call is the asymptote. So you can go to from different direction. That's what is we call is the vertical asymptotes, right? Okay, so now let's take a look at what is the horizontal asymptote. Okay, so in here, one thing you need to be careful. If it is the vertical asymptotes here, then the way you write it is x equal to some values here, right? Okay, so now let's take a look at the horizontal asymptote. So just like we defined as the vertical asymptote is some value, your function can get very close to. So this is, we call this a horizontal asymptotes here. So that means it could be something like this, right? So this is my b's here, right? So that means your function can go like this. It can get closer and closer. So the function can go like this. Right, so this is my f of x functions, right? That means this function can get closer and closer to this value of the b, but it will never touch it, all right? So the way we write the horizontal asymptote, because this is a line on the y-axis, so I say y equal to b here, all right? Or the asymptotes here, you can go to the other directions, right? So for examples here, if this is your asymptotes here, so this is your asymptote, right? So this is a b. You can have a function go to like, you can have like something like go this way, right? You can go this way, right? So then it still is going to get closer and closer to this line, and then, but never touch it. So this is what we call is the horizontal asymptote. So one thing you need to be careful here, right? Is that means if you say it's a horizontal asymptote, the way you write it is y equal to b here. Okay? Okay, so now so the next thing we're going to talk about is how do I find the asymptote if you give me a function. So before we do that, let's try to use our transformation skill, try to do a graph here, right? Or let's try to kind of practice what we learned before. Okay, so this is rational functions. And so we know the parent functions. Okay, so the parent function for the rational is f of x. We learned that in the chapter 2 is 1 over x, right? So the 1 over x, and also we said when we do this type of the graphs, we need to know few key points here, right? So, okay, so let's see here. Let's put here few key points. Okay, so now we can do the transformation according to those few points here. So this is f of x. Okay, let's start. Of course, x cannot be 0, right? Because 1 over 0 is not defined. So I say 1. So what is here is 1. If I say x is 2, what is here? This is 1/2. How about x equal to 1/2 now? What is here? It's become 2, right? You flip. So the same way, if you use -1, what do you have here? Hey, -1. And if you have -2 here, you have -1/2. You have -1/2 here. What do you have here? -2 here. Okay, so like always, let's try to plot our parent functions here, right? So in here, in order to make it easier to read, so I want to like here, this is 1, 2, 3, 4, right? So I use the 2 as 1s here. Okay, so this maybe make the graph is a little better to read, right? So this is 1, 2, right? So this is 1, 2, like that, okay? So that's what we want you to be able to look at the graph better. Okay, so now let's try to plot the parent functions, right? Parent function 1 and 1. So here is my first point, and the 2 and the 1/2. So this is my second point, and the 1/2 is 2. So it's my third point, right? Okay, so remember the parent function, it will getting closer and closer to what? To the both x's and the y. So the parent function, have the asymptote of x-axis and y-axis, right? Now let's take a look at the -1, -1. So I have this is my point. Then the -2, I have a what? I have a -1. The -1/2, I have a what? I have -2s here, right? So the same way, these were getting closer, 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 closer. This is my parent function for the what? For the rational. I use the dotted line is because what? Because it's not my final graph yet. Okay, so now let's take a look at my first transformation. So x minus 3 compared to x. So what is this transformation? You should remember. What is this one? So this is move to where? Move to right, right? So move to right. How many units? 3 units, right? Okay. So this is move to right 3 units. So let's use okay, so I'm going to use red. So the 1 going to move to where? 1, 3 units. 1, 2, 3. So 1 going to move to here. Okay. Then these numbers are going to move 3 units. It's 1, 2, 3. So going to move to here. And this unit, so this number going to move 3 units, right? 1, 2, 3. So it's here. And so now, okay, now your used to be, this is your asymptotes, right? So that's a y-axis, you need to move 3 units also. So it's 1, 2. Okay, so this one's, okay, so this one is moving to here. I need to be careful here. All right, so this one moving to 1, 2, 3. Yeah, it's in fact here. Then the asymptote is kind of moving also, right? So the asymptote is moved. Okay, so now you can, so because the y has to move, so that means in here, your parent function, so this is like go like that, right? Okay, now let's take a look at this ones here. So 1, 1 going to move 3, 1, 2, 3 going to move to here. And this is 1, 2, 3 move to here. This is 1, 2, 3. This is move to here. All right. So now you do the same thing. This is not my final graph yet. So I still have a dot, 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 and then here, right? So it's a continue. So this is my the transformation to the right 3 units. Okay, now let's take a look. What is this 2 mean? So this 2, what is this 2 means here? That means the vertical what? Vertical stretch, right? How many? 2 units, right? Okay, so now that's all I need to use my, okay, so that means this one used to be 1, right? You times 2. So 1 times 2 is what? 1 times 2 is 2, right? So I go down, go up to here. Okay, so it's go up to here. Then this one is 2s, right? So 2, you times 2 is what? It's 4. So here, I go up here. Okay, then this is 1/2, you times 2. What is 1/2? You times 2 will be 1. So you go here, right? All right, so that's why this is my, so this is the asymptote still here, right? So this is my final graph. That's why I use the solid lines here. So the same ways here, this is the point, this is -1 times 2 will be -2 here. This is -1/2 times 2 will be what? -1. This is -2 times 2 will be what? -4, right? So it's in here. So now you still have, this is asymptote, this is asymptote. So the graph is going to look something like wow, this one is really graph ugly here. Okay, so need to be careful. All right, so here, this is difficult to do that. So here, oh, okay, right? Okay, so here, so this will continue to the asymptote y-axis. This is how do we use the parent function and try to graph it. Okay, so now let's take a look at the second one here. The second one, this is 3x plus 5 equal to the x plus 2. So I'm still first, let me try, right? So let's try to plot my parent functions, right? So by parent function, just like we did before, so let's make this mark is 1, 2, 3, 4. It's easier to see 1, 2, 3, all right? So this is 1, 2, 3. All right, so this is 1, 2, 3. Okay, so now still I have a 1, 1, 2, negative 1, 1/2 is 2. So this is still my asymptote here. X, Y, X is my asymptote. So negative 2 is negative 1, right? Negative 2. So this one's here. Negative 2 will be negative 1/2 here. Will be 1/2. Negative 1/2 is negative 2 here. All right. So this will be my parent function. Okay. Now, oh boy, how do I do this? Okay. So this one's here, because they have the equal. So you will need to use the long divisions. So if you still remember the long divisions here, right? So like we just did for our previous video. So this is 3x plus 5. This is x plus 2. So you say 3. So this is 3x and plus what? Plus 6. Then you minus 1. So what here is minus 1. So you will have a 3 minus 1 over x plus 2 here. Okay, so now let's use the parent function concept and see what happens here. All right, so the first, this is my transformations here. Okay, so for this transformation, what we did here, so this is a shift, move to which one? Move to the what? Move to the left. How many units? 2 units, right? So you move to the left 2 units. Okay, so let's start. All right, so let's start here. So did move to the left 2 units. So first 1, 1. This one going to 1, 2. This one going to move to here. And then this one is 2 units going to move to where? So this is 2 units, right? So 1, so it's moved to here. And this one has 1, 2. This one move to here, right? Okay, now your asymptote going to move 2 units also, right? So this is kind of like become your new asymptotes here. All right, so now you can plot this side. This side will be, this is what is this transformations, right? Okay, let's take a look at this one here. This one, 1, 2. So this one move to here. This one, 1, 2. This one move to here. This one is 1, 2. This one move to here, right? Okay, now this will be your other ones here. Okay, now let's take a look at what is this one. What is this transformation? This transformation, so this is the second transformation, right? So this is a flip. So this we call this a reflect over what? X-axis. Right, so this is a reflect over the x-axis. So let me reflect it. So I use the blue one. Okay, so reflected. So this one go to here, this one go to here, and then this one reflect to go to where? Go to here, right? So now I reflect it. So this is my reflecting here. So the asymptote still the same. Okay, so this one's here is reflect over to where? Reflect over to here, this one. So 1, 2, reflect to here, reflect to here. Then this one will reflect in where? This one we're going to reflect over. Okay, so here. Okay, so be careful here. All right, so, okay, this one we get rid of. Okay, so this one, okay. So this one is 2, right? So 2 going to reflect into the negative 2 here. All right. All right, so after you reflecting, so here is your blue one, see here, right? Still have this asymptote, but now this is still not my final one. So my final one will be what? What is this one? See here, 3. What's that means? Moving what? Move up 3, right? Move up 3 units. So I'm going to use the green to be my final. So this one move up to 3 units. So it's 1, 2, 3. So it's this one here. And this one move up to 3 units. It's 1, 2, 3. It's move up to here. This one move up to 3 units. It's 1, 2, 3. It's move up to here. Because right, you move up. So your y, your x-axis, you need to kind of like asymptote, you need to move up 3 also, right? 1, 2, 3. 1, 2, 3. So your x-axis is kind of moving up to here. All right. So let me kind of get rid of the red one, so that it would be better to get rid of the black one here, the red one here. So maybe you will see better. Okay, so we'll not be so confused here. All right, so this is the black one. So let's get rid of the black one here. All right, okay, so now in here, so it's 1, 2, 3. Okay, so just make sure I have that. Okay, so now your green one, okay, so it's moving up 3. So now this is your final. Okay, so don't forget your x-axis asymptote, you need to move up to 3. Okay, let's take a look at the bottom ones here. So this one move up to 3. So 1, 2, 3, move up to here, right? And this one move up to 3. So 1, 2, 3, move up to here. This one is 3, 1, 2, 3, move up to here, right? So remember your red asymptote and green asymptote. So this function will go like this. All right. Okay, so that's how do you graph the rational from the parent functions, right? So from the parent functions here. So remember when you try to graph from the parent, right? Okay, so if you do from the parent, and don't forget you need to shift your asymptote also, right? Shift the asymptote according to what? According to the transformation. So like in here, we need to shift the y-axis to here. We need to shift the x-axis up. It's because of the transformations here. Okay, so those are how to you graph by using the parent function. Okay, so now we see how important are the asymptotes here, right? And from the parent function, you need to be careful. But how about you give me any rational functions? How do I find the asymptotes, right? So in fact, it's pretty easy here. Okay, so the first one's here, the vertical asymptote is easy to find. So the vertical asymptotes here, right? So the vertical asymptote is all the x values here, which make the denominator equal to 0, all right? All right, so now, okay, so now what is the horizontal asymptote? Okay, so for the horizontal asymptote, so you need to remember this, like this is Rx, right? So it's a rational function, it's a true polynomial. Let's say the top polynomial is xn plus a1, an minus 1, xn minus 1, to the a1x plus a0. Then your buttons here is another, right? This is my p-axis, right? The bottom is another polynomial, it's bn plus bn minus 1, xn minus 1, to b1x plus b0, right? This is a q-axis here. So the most important part for the asymptotes here is you decide by the power, because so in here, you compare the top power versus the bottom power. Because when the x approach to infinity, the only thing matter is the highest exponents here, all right? So we say here, this is the rules for the asymptotes here, okay? So if n greater than n, right? So so if n greater than n, that means the top running a lot faster than the bottom. So we say no horizontal asymptote, okay? Then we say no horizontal asymptote. And if n is less than n, that means the bottom go very fast. That means the bottom going to become infinity. So that's why we have we have an asymptote, because become the at y equal to 0. That means the asymptote going to approach to the x-axis, right? Right. So now if the n equal to n, so if the polynomial, this is degrees of phi, and this is degrees of the phi here, right? So then the horizontal asymptote, so this is horizontal also. Then the horizontal asymptote will just be what? Will just be y is equal to what? The front coefficients. All right, so you just compare the front coefficient. So it will just be the an over bn here. Okay, okay, so now let's try. See, how do I find the vertical asymptote and the horizontal asymptotes here? So what do we need to do here? First, step one is what? Okay, so let's do the step one. What do we need to do? Let's factor. Okay, so the factors here, so this is Rx, right? Okay, so I have here, this is Rx here, so like the factors here. Oh, this is 3x minus 2x minus 1, so this is 3, 1, 1, 1. And okay, so I have a 3x plus 1 and x minus 1. Right? Let's see, is that working or not? Right? So the 3x squared, yes, that's working. Yeah. Okay, so the next one is 2x and the x. Okay, so it's a minus. So this is 2 minus 2. So this is plus 3. So I need to have like this. Is that working? Let's say here 2x squared, 2x, 4x minus 2. Yes, it worked, all right? So after you find it, okay, so now let's take a look, the vertical asymptote. So we can write is the VA. So remember the vertical asymptote is all the values, so you make the denominator equal to 0. All right, so that means 2x minus 1 equal to 0. What is x here? X is equal to 1/2, and x plus 2 equal to 0. What is x here? X is negative 2. So I have 2 vertical asymptotes here. So that means 1 is here. This is 1/2. So your function going to getting closer to this line and the negative 2. See here, right? So I have 2, the vertical asymptotes here. Put it into different colors here. Okay. Okay, now the horizontal asymptote. Okay, so horizontal asymptote also is pretty easy. Now we use HA. So let's see the largest exponents. The largest exponents, this is x2. This is x2. So they have the same x2s, right? So what is the horizontal asymptote? It will be y equal to what? 3/2. That means in here, there's something here. This one will be the y. This is a horizontal asymptote, right? So it had 3 halves. And these two lines here, this is x equal to the -2, x equal to the 1/2. Both of them, this is the vertical asymptotes here, right? So it's pretty easy here. Okay, now we combine all these informations. Now we need to know how to graph here. Okay, so I'm going to do a step-by-step and then showing these examples here, right? Okay, so let's take a look at how do I sketch a rational function. This is not easy, but it's kind of like you need to be careful. Step number 1, right? Factor both, right? So I both the numerator and the denominator. Okay, so let's try to factors here, right? So factors here. Okay, so this is step number 1, and I can factors here. So let's see here. This is what? This is x plus 2, x minus 1. It's good. All right. So this is all right. So now the top here is 2. Wow, we have 2x minus 1, x plus 4. All right. I hope yeah, this one's here. Okay. Okay, so this is Rx, right? So this is Rx. Okay. Now the second step, let's say, in order to help here, second steps here is find the what? Find the intercept. Okay, so I have an x-intercept and I have a y-intercept. Okay, so the x-intercept, how do I find the x-intercept here? X-intercept, I set what? Y equal to 0. Y-intercept, what I set x equal to 0, right? Okay, so let's take a look. So that means your graph, this will help to, where your graph going to touch here, right? Okay, so x-intercept, okay. Okay, so let's take a look here. Okay, the y-intercept is what? Y-intercept is when you set which one equal to 0, x equal to 0. So you put x equal to 0, here. What is that? It's -4 over -2, so it's 2. Good job. So let's see, it's 2 here, right? So now let's still make make the graph a little bit bigger. So this is 1, 2, 3, 4, 5. Okay, let's do this. 1, 2, 3, 4, 5. Okay, so I get a y-intercept is 2. So this is 1, 2, right? Okay, so that means I'm going to go through this point, right? That's y-intercept. Okay, so far so good. Okay, so now the next things here, I'm going to set the x-intercept. Okay, so how do I set the x-intercept? With that, what? Y equal to 0, right? So if y equal to 0, your denominator cannot be equal to 0. That means your numerator going to become equal to 0, correct? So that means you're going to have a 2x minus 1 equal to 0, x plus 4 equal to 0. So what is a 2x minus 1 equal to 0? X equal to what? 1/2. What is here? X equal to what? 2x, x equal to -4, right? Okay, so let's plot the x-intercept. X-intercept, x equal to the 1/2. So going to go through here, and x going to go to where? -4, so it goes through here. Okay, so far so good. Now let's take a look at the vertical asymptote. All right, so then the step number 3 is here is find the vertical asymptotes here. Okay, so the step number 3. Okay, so the step number 3 is find the vertical asymptote. Remember the vertical asymptote we just defined. What is vertical asymptote? It's all the denominator equal to 0. The x make the denominator equal to 0, right? So vertical asymptote will be x plus 2 equal to 0. So what is x here? X equal to -2, and also x minus 1 equal to 0. So x equal to what? X equal to 1, right? So this is my vertical asymptotes here. Let's try to see we can graph this ones here. Not x equal to 1, so it will be like this. So this dotted line, x equal to the -2. Well, this kind of too big. It doesn't look good. Okay, let's. All right. Let's try to use my blue color as the asymptote. All right. So x equal to 1. So this is my asymptote here. And x equal to -2. So this is my asymptote. That means when I do my graph, they're going to getting very close to these two lines here. Okay. Okay. Now this is the next thing here. Okay. So after I find it, you graph each, right? So just here. Then the next thing here is number 4. What I want to do here. So I want to find the horizontal asymptote. Okay, so vertical asymptote is VA, horizontal asymptote is HA is here. Okay, so now let's see here, the horizontal asymptotes. Okay, so you look here, you say, hey, you say, hey, here, the power here, this is x squared. Oh yeah, that's good. So they equal, so I know the horizontal asymptote will be the ratio of the coefficients, right? So will be 2/1, so it's equal to what? It's equal to 2, all right? So now we say that this is my horizontal asymptote, 1, 2, so here, okay? So that's good. So here, okay, so this is, I just graph all that. So we'll have 2 vertical asymptote and 1 horizontal asymptote. Okay, and then now, okay, so I can start to sketch the graphs here, right? Okay, so this is the problem number 5. This is step number 5 here, right? Okay, now I do a sketch the graph. Okay, okay, so let's see how easy we have that. Okay, so I need to know which one. So I know my function is going to cross those, right? So my so I have those intercept 1/2. I have this intercept 1/2, -4. Okay, so now let's scratch here. In order to sketch that correctly, right? So let's do this. Okay, so let's see here. Let's do a table here. Okay, let's do a table, and for this table, let me see here. Maybe do like this. All right, so put a button here, have more space here. Okay, so my function value, this is 2x minus 1, and this is x plus 4, and this is x plus 2, and this is x minus 1 here, right? Okay, so now I will have, because I have x-intercept at -2, right? So I will say the -2 from the left-hand side. Okay, that's what is my notations here. That means on the left-hand side of a -2, and I have -2 from the positive sign, right? That's from the right-hand side. Then my next x-intercept is what? My next things here will be vertical. Oh, I'm sorry, this is not intercept. this is the vertical asymptote, right? So next asymptote is 1. So from the left-hand side, 1 from the positive side here, right? Okay, so now I'm going to do this. I'm going to take a look. This one is positive or negative here. Okay, so for any number from the left-hand side of negative 2, 2x minus 1 will be negative. X plus 1 will be positive. And this one is negative, right? Because if you put negative 3, so it's negative. So the whole things here, these things will become what? It's negative, right? Okay, so that means, what's that means? That means I'm going to approach to the negative 2. I'm going to go what? Going down here. All right. Okay, now the next one's here. Take a look here. If the positive, negative 2 from the right-hand side, so what happened to 2x minus 1? Going to be negatives, right? If you don't believe, you choose negative 1 to put in here. Then x plus 4 will be positive. And then you choose negative 1, put on the bottom, will be positive, right? Will be negative. Right, positive and the negatives, right? Okay, so now you have what? So what is this things here? This whole things will give you what? It's positive. Now let's take a look this one's here, right? So the 1, right? The 1, if you put on to the, okay, so you choose 0, so this will be the negative, positive, positive, negative. So what do you have here? Okay, so let's see from the negative, from the left-hand side of the 1. So if it's 0, so it's negative, positive, positive, and negative, right? So from the right-hand side, 1 here. So this is 2x minus 1, x plus 2x minus 1 here, x minus 1. So, okay, so it's negative, positive. The top here is 0. Oh, okay, here is a positive. Mix up here. So the whole thing's here, this one going to be negative. All right. Okay, so then the last ones here is on the right-hand side of the ones here, right-hand side of the one, so you put like a 2 in there. So 2, so this is a positive, 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 positive. Okay, so I have a positive here on the right-hand side of this asymptotes here. Okay, so now let's take a look. All right, so now you're here, so that's how I'm going to graph it, right? Because I know, okay, so take a look at this, how I'm going to graph it. Because I know I'm going to passing through here, and my y going to touch the asymptote. So from the left-hand side of negative 2, my graph is going to go down. And so that's why I have my graph go like this, right? It's an ugly one here. All right, so but here, that's what we have here. So your graph going to passing through this point here and then going down, this is the asymptotes here, right? Of course, this is like smooth curve. I have a hard time to do a smooth curve here, but it's kind of like the smooth curves here, right? And this is a smooth curve. And then from the positive side of the negative 2, they say, hey, you need to go to the negative, positive, right? So that means you go up here, then you're touching, you go through the y-intercept, you go through the x-intercept. So what do you have here? So you have these ones here, right? Then you go through here, then you're going down. Because when you do the y negative, 1 from the left-hand side is negative. So that's why this leg going down, see here. Then the same way is here, right? So I say, when I approach to this asymptote from 1 to the positive, is going up. So I know my other graph here going up, but this one has to touch has to go through close to my asymptotes here. All right, so that is what is my graph. We need to be kind of very careful here. Okay, so the last things here, right? So we need to take a look at the domain and the ranges here. I think we need to go back to our previous two problems we did not. So the domain and the ranges here. Take a look at the ranges here, right? So the range is here. Let's take a look here. The range. So the range is from negative infinity to the positive infinity, except what? Except this number, this asymptotes here, the horizontal asymptote, it will never be that numbers, right? So the range will be what? Y in the real number, except what? Y is not equal to what? Not equal to 3, correct? So a horizontal asymptote is 2, I'm sorry, horizontal asymptote is 2, so y is not equal to 2 here. Okay, so the same things here, let's take a look at the domains here, right? So the domains here, okay, so let's try one more time. X can be from negative infinity to the positive infinity, but x cannot be these two, right? So that means, so that's why as I said, x is in the real number, except x cannot equal to the negative 2, and x cannot equal to the 1/2 here. Equal to 1. I'm sorry, the vertical asymptote is 1. All right. So that's basically the domain and the ranges, right? So the domain and the range is like a range, you need to get rid of the horizontal asymptote. Domain, you need to get rid of the vertical asymptote. Okay, let's go back to our previous problems here. We did not do the domain and the ranges here. Okay, so like for here, right? So for this province here, all right, so for this province, right? So this province here, okay, so let's see here. This problem, this is 3 minus 1 over x. So this is my vertical asymptote at x equal to 2. This is my horizontal asymptotes, right? So the range need to do what? Range is r, but y cannot be equal to what? The move up 3, so the y cannot be 1, 2, 3. Y cannot be 3. Then the domains here is belong to the r, but the x cannot be in the vertical asymptote. What is vertical asymptote? It's negative 2. Okay, so let's try to take a look at one more. This one's here, right? So this one's here the same way. So the range is here is y can be everything. So y belongs to the real number, but y cannot be what? Horizontal asymptote. Y cannot be 0. So the domains here is x can be real number, but the domains here. So what is the vertical asymptote for here? The vertical asymptote is 3, right? So then the x cannot be equal to 3. And that's it, right? Okay, so for this section, the first video, we're going to stop here because this is kind of a long video. We're going to do the second part in our second video so we can break this lesson out so we don't, we don't have one video, it's so long for that. Okay, all right. So you have a good day and looking forward to talk to you on our next videos here. Okay, bye.